All right, we're going to finish up our 2.7, 2.8 lesson here with graphing inequalities in two variables. You may remember this from Algebra 1. This is where you have to graph a boundary line and then test a point on either side, usually 0, 0, and shade appropriately. So as we look at this equation here, or this inequality, we want to treat it just like it's an equation, like y equals negative 2/3 x plus 3, and graph that line. The fact that it's less than or equal to, the or equal to tells us that it's going to be a solid line that we have. Okay, that means it's going to be a solid line. Okay, so let's graph this like we normally would. Our y-intercept is 4. And our slope is negative 2/3. So from left to right, we want to go down. 2 over 3, 2/3. And we'll get a couple points in either direction. Okay, here's that solid line. If this would have just been a less than symbol right here, then we would have had a dashed line instead. Now what we want to do is test a point on either side of that line. The easiest point to test is 0, 0. Okay, so we're going to put 0 in for x and y. And what we end up getting is 0 is less than or equal to 4 when we put that into the original inequality. Okay, that is a true statement, which means we're going to shade where 0, 0 is. Okay, 0, 0 is right here. We just found out that that's a solution. That means that everything below the line is a solution. So we're going to shade everything that we have here below the line. We're going to shade everything. Okay, anything below that line is a solution, including the points on the line as well, because of the or equal to that we started off with. In the next problem, well, let me just go back to this one real quick. Had we tested 0, 0 and it was not a solution, let's say this would have been a false statement. 0 is less than or equal to, maybe it was negative 4. Well, then what we would do is shade where 0, 0 is not. So then we would have shaded above the line. Because if 0, 0 is not a solution, neither is any point below the line, and we would shade above. All right, the next problem here. Notice how we don't have a or equal to line underneath that. That means that we're going to have a dashed boundary line. This is in standard form, so we can get intercepts by putting in 0 for x and 0 for y. So our x-intercept is going to come from 3x equals 16. Now we can just use an equal sign when we are finding the intercepts, because we're just finding a point. So that would be 5.3 repeating as an x-intercept. Okay, which is kind of ugly, isn't it? So let's just find our y-intercept here, and then go from there. Our y-intercept would be negative 4, because we have negative 4y equals 16. Y would equal negative 4. These are our intercepts right here. Oops, y would equal negative 4. Okay, so that I can put down. That's pretty easy. The slope, remember, is negative a over b, or the opposite of a over b, which would be 3/4. So if I go up 3, 1, 2, 3 over 4, up 1, 2, 3 over 4, down 3 over 4, get a few more points, and I'm going to dash this line that I put in here, because none of the points that are on that line would be a solution. Okay. You could put this into slope-intercept form, subtract that 3x over, so we'd have negative 3x plus 16, and then divide by negative 4, which would mean that we'd have to flip that inequality since we're dividing by a negative, and we'd have 3/4 x minus 4. Okay, well, look at this tells us. The y-intercept is negative 4. We already know that. We plotted that first. The slope is 3/4. We already know that. We got that from standard form. So we can get those same things from standard form. Okay, so what does this flipping the inequality do to it? Well, let's go back to our original standard form inequality, and let's test 0, 0 in that. We would get 0 is less than 16 when we put that in. That's true. Okay, which would mean that we would shade below the line. or excuse me, not below the line, where 0, 0 is. 0, 0 is right there. So we're going to shade where 0, 0 is because it's solutions. It's a solution. We're going to shade everything above the line. Okay? If we were to use the second inequality that we got and put in 0, 0, we would have 0 is less than negative 4 if we tested 0, 0. Okay, using this other form of the same inequality. Well, that is 0 is greater than negative 4. I think I said less than. 0 is greater than negative 4 is true, and that is going to give us the same result. Since this is true, we're going to shade up above that line again. So either way, we're shading where 0, 0 is. Okay, so this really wasn't all that necessary. Even though this was ugly, we still got our slope and our y-intercept from it just like we wanted to. Oh, and look at 5.3 repeating. Look at right where this is crossing on the x-axis. 5.3 repeating. Okay, just like we thought it would. All right, last one here is an absolute value inequality. Okay, so we're going to graph this just like we graphed our other absolute values. We have a value of negative 2 and a vertex of 3, 4. So this thing's going to be opening down. Sometimes I give myself a little reminder like that right away. It's going to be opening down. The vertex is at 3, 4. So right about here. We're going to be going down 2 over 1 at the right side of the absolute value. And then we can reflect that going the other way. I just noticed that as I'm doing this, I just noticed that this is not an or equal to, so it should be a dashed line. I think I can fix that kind of by doing this sort of thing here. Make this dashed. Okay, this should be a dashed line. Good enough. Okay, now let's test 0, 0 again. And the reason we can test 0, 0 is because it's not on the line. If 0, 0 is on the line, you got to test a different point. But if it's not on the line, test it. It's the easiest one. So if we put 0 in for x and y here, what we get is 0 is less than negative 2 times the absolute value of negative 3, because 0 minus 3, and then plus 4. Well, this is 3. So you have negative 2 times 3, which is negative 6. Plus 4. 0 is less than negative 2. That is false. That's not true. So that means that 0, 0 is not a solution. Okay, so right here, that's not a solution. That means nothing on that same side of the absolute value is a solution. All the solutions lie on the other side, or inside our absolute value.